Hey learners, this is Dr. Rishi from the Learners Academy, and today we are going to solve some numerical examples from the topic work, energy and power. We have already done videos that described this topic theoretically in the past. The links for the same videos is given in the description box. If you have any queries, you can go to those links and check them out. So without losing any time, let's go ahead and check out these examples. So let us go ahead with the first example. This is solved example number 3. We have 500 liters of water is raised from first floor of a house at height 4 meters to its third floor at a height 12 meters. State whether the potential energy of the water would decrease or increase. Find the increase in the potential energy of the water. Now, what do we have to look here? What is happening with the water? The water is raised, meaning the height is increasing. We are going from 4 meters to 2 meters. Now, we know that if we increase height of a body, if you take body from a lower height to a higher height, obviously there would be an increase in the potential energy because it is mgh. So there would be increase in the potential energy. So we can clarify this first thing that is there, that is increase in the potential energy. So there is increase in the potential energy of the water. Now let's see how much increase would be there. So first we need to find the mass of the water. Mass is not given, volume is given, it's 500 liters and mass of 1 liter of water is 1 kilogram. So we can say that the mass is 500 kilograms. Now H1 is the height where we have started raising it from, which was 4 meters, and H2 is the height where we have taken it to. Now since there is H2 is greater than H1, there would be increase in the potential energy. Now how are we going to find it? There are two ways to find this increase in potential energy. First is you find the potential energy at point 1, we'll call it as PE1, it would be mgh1. And then we'll have it PE2, which would be the potential energy at 12 meters, which would be mgh2. And then we can subtract them and we can see that the increase in the potential energy. So increase would be potential energy at point 2 minus potential energy at point 1. So that effectively would be mgh2 minus mgh1. Now we can see that mg is common, so we can take that mg common here and we can have h2 minus h1. We put in the values and get the final answer as 4 times 10 to the power of 4 joules. So this would be the increase in the potential energy when we take it from point 4 h1, which is at 4 meters, to point h2, which is at point 12 meters. Now you can quickly make a note of this so that we can go ahead with the next example. The next example that we are going to do is example number 5. It is talking about a dam. Water falls at the rate of 1000 kilograms per second from the height of 100 meters. We have to calculate the initial potential energy. Now since the dam, we have a dam which is storing the water in it, so it would have a lot of potential energy, and we are assuming 60% of the energy of the falling water is converted into electrical energy. So how efficient is our machinery of converting it into electrical energy? It is 60% efficiency. So we use this to find the power generated. Okay, G is to be considered as 9.8 meters per second square. So let us go ahead with the first part that is there, that is to calculate the initial potential energy. So we know the mass is 100 kilograms and the time taken is 1 second and gravity is 9.8 meters. Acceleration due to gravity is 9.8 meters per second. Height is 100 meters. The formula would be mgh. So we can write the values mg, this is mass, this is gravity and acceleration due to gravity, and this is the height. So it comes to 9.8 times 10 to the power of 5 joules. Now energy available from the falling water is its initial potential energy, so it would be mgh, and the efficiency is 60%. So 60 upon 100 times mgh, so that would be 0.6 mgh. So this is what we had got. This is my mgh ka value. So the power generated would be electrical energy divided by time, so it would be 0.6 mgh upon time. Time here is 1 second. So we have to find the power generated per second. So we put in the value. We can directly put the value as 0.6 times 9.8 times 10 to the power of 5, and we'd end up with 5.88 times 10 to the power of 5 watts. We can also write it as 5.88 times 10 to the power of 2 kilowatts, or 588 kilowatts. So this can also be considered as an appropriate answer. So any one of these two would give you full marks. Quickly make a note of this so that we can go ahead with the next example that is there. Now, this is example number 8. Again, this is also a solved example. It is talking about how fast should a man weighing 600 newtons run. So we have a guy whose mass, whose 600 newtons, whose weight is 600 newtons, and he is running. So the kinetic energy is 750 joules. Now generally weight is given in kilograms, here the weight is given in newtons, and here gravity is 10 meters per second. So let's see how we can find it. Now we know that weight is equal to mg. So first we find the mass of the person. So weight is 600 is equal to m times g, or we can say that the weight of the mass is, the mass of the man is 60 kilograms. His weight was 600 newtons. So we have the value of m, and we need to find this value of velocity. So we can say that 750 times half times 60 times v square. So 750 would be equal to half times 60 times v square, or we can take the 60 on the other end, it would get divided, this 2 on the other end, it would get multiplied. So we'd end up with v square is 2 times 750 upon 60. Calculating out, we'd get v square is equal to 25, or v would be equal to 5 meters per second. Now we can also be written as v is equal to plus minus 5 meters per second. Now if it's minus 5, so if the man is standing here going in this direction, it would be 5 meters per second. If he runs in this direction, it would be minus 5 meters per second. So you don't have to actually write these down. This would be your final answer, because we are considering the man going in the forward direction only. Now let's go, you can quickly make a note of this, and then we can go ahead with the next part. The next question is solved example number 11. So we have first, now this is where numbers are not given, we just have to compare. It's slightly different example as compared to what we've done so far. Here everything is given relatively to the other part. So there are two scenarios that we have to consider. So they're saying that for the same kinetic energy of the body, what should be the change in its velocity if its mass is increased 4 times. So in the first case we say mass is m, in the second case we say velocity, and in the first case the velocity is v1. Final mass is m2, it is 4m, 4 times my initial mass, and its velocity is remaining same. Now we have to compare them. So since the kinetic energy remains the same, half m1 v1 square should be equal to half m2 v2 square, giving me half mv square should be equal to half times, now this is m2 would be 4 times my m1, should be equal to multiplied by v2 square, giving me v2 square would be equal to, this 4m goes on the other side, it gets m gets cancelled, this 4 gets multiplied, and this 2 would also get multiplied there. So we can effectively write v2 is equal to, this 4 would be getting divided. So we write V2 square is equal to 1 by 4 V square, or V2 square would be, so you take the square roots on both the sides and we take V2 would be equal to half V. That means the velocity should be halved. So if we want to keep the kinetic energy same, then we pretty much can say that the kinetic energy is directly proportional to the mass, and it is directly proportional to the root of the velocity. Okay, so since the kinetic energy remains the same, velocity would be halved. Quickly make a note of this so that we can go ahead with the next example. In the next example, we have calculate the kinetic energy of a body of mass 0.1 kilogram and momentum 20 kilogram meters per second. Now here the momentum is given and we have to find the kinetic energy. So let's see how we can do it. We know that momentum is 20 kilogram meters per second and mass is 0.1 kilogram. We know that kinetic energy is half mv square, momentum is mv, so we can write v is equal to p upon m. So v square can be written as square of this quantity. So we can say that kinetic energy is half times m times p upon m square. So it can be written as k is equal to half times m times p square upon m square. Now this square would get cancelled with this m and we would be left with, so we would be left with p square upon 2m, giving me kinetic energy. So I put in the values. So k here was 20, so I've put in that value and I've divided it by 0.1. Final answer being 2000 joules, or we can say that 2 times 10 to the power of 3 joules. We can also call it as 2 kilojoules. You can quickly make a note of this so that we can go ahead. Now the next example is from the exercise. This is not solved in the book, so I'm solving it for you. We have a box of weight 105 kilogram force. Now units are crucial here. They are juggling between the units. Gravitational potential energy stored in it equals 14,700 joules. Find the height of the box above the ground. So we are having a box like this and we are raising it from one point to another point, point A to point B, and its energy at the point B is given. The energy at point B is 14,700. So we have to find how much this height from A to B is. So we have the force due to gravity is given as 150 times 9.8 newtons per kilogram. Again, it's written in a very interesting way here, because here the weight is given in kilogram force. So we have to convert it into newtons. Now 1 kilogram force, we know that 1 kilogram force is equal to approximately 9.8 newtons. This is what we had studied in the first chapter, so we are using this conversion here, which gives me mg is equal to, so this is the force of gravity, so this is the weight in newtons. So we can clearly see that gravitational potential energy is mgh, so we put in this. So we've put it in the correct units and it has given us the answer as 10 meters. Now this is a crucial converging factor that you need to know how we are going to convert something that is there in a kilogram force, some weight that is there in kilogram force, into newtons. Okay, here gravity is also given as 9.8 newtons per kilogram. We can use it directly in this case. So let's quickly go ahead, and you can quickly make a note of this, and then we can go ahead and check out the next example. The next example is example number 4, which is telling us that body of mass 5 kilogram falls from a height of 10 meters to 4 meters. So now here in the previous case you were taking the body from point A to point B, it was raised in height. In the current scenario we are taking it the other way around. That is, the body is at point A and it is being dropped from 10 meters to 4 meters. So it has come here. Now we have to calculate the loss in the potential energy of the body, the total energy possessed by the body at any instant. So let us quickly go ahead and see what we get. So for the first case, we have mass of the body is 5 kilograms. So potential energy at height 10 would be mgh. So it would be 500 newtons, 500 joules. Potential energy at 4 meters height would be mgh. So it would be 200 joules. Loss in potential energy would be 500 minus 200 joules. So that would be 300 joules. Now, total energy of the system would always remain the same. So we can take any point. We find this point at the topmost point would be the best option for us because we have already calculated the potential energy at that point. So the total energy would be addition of kinetic energy and potential energy. So at height 10 meters, the kinetic energy would be 0. So we can say that total energy is kinetic energy plus potential energy. So the total energy of the system would be 500 plus 0. So that is 500 joules. Quickly make a note of this so that we can go ahead with the next example. Now this is a very interesting example which says that a block A whose weight is 200 newtons. Now here again weight is given in newtons. Always read the question properly. In previous cases it was given as kilogram force. It's pulled up a slope of length 5 meters by means of constant force F. So we have this constant force F of 150 newtons and it is taking it in this direction. Okay. Now what is the work done by the force F in moving the block A 5 meters along the slope? So we are taking it from here to here. The block is going to undergo displacement of 5 meters and we have to find the work done. Then by how much has the potential energy of the block increased? So we have to find the potential energy, how much the potential energy is increased. So potential energy would take into consideration only the difference in the heights, and then there would be a difference. Obviously there would be a difference between the work done and the increase in the potential energy, because it is doing the work along a direction and it is increasing the height. The potential energy would be depend on increase in the height. So first case, the work done would be force multiplied by displacement. In the direction of force it would be 150 multiplied by 5, so that would be 750 joules. In the second case, the potential energy gained by block would be mgh. Here h is 3 meters, so it would be 20 multiplied by 3 meters, so that would be 600 joules. So there is a difference of 150 joules, and this is because the 150 joule energy is used in doing the work against the friction. We are sliding the box, so there would be a friction at this point when we push it up. Okay, so that sounded quite simple. So quickly make a note of this so that we can go ahead with the next part. The next question that we have is question number 12 from the exercise. We have two bodies of equal masses are moving with uniform velocity v and 2v. Find the ratio of their kinetic energies. So we basically have two bodies moving with their masses are equal and they're moving with uniform velocity. एक का velocity double है पहले की velocity से. So let's go ahead. So the velocity of the first body is v1, velocity of the second body is v2. Now we know that the kinetic energy is directly proportional to V square. So we can see that kinetic energy K1 upon K2 would be V1 square upon V2 square. So it would be equal to V1 square upon, ये दूसरे वाले का क्या है, तो it is 2V. So we can put it as 2V square. So it gets V square upon 4V square. V square cancel हो गया, उनका ratio हो गया 1:4. That means the kinetic energy of the second body would be 4 times more as compared to the kinetic energy of the first body. Quickly make a note of this so that we can go ahead. Now, we have a ball of mass 0.5 kilograms. We are slowing it down from the speed of 5 meters per second to 3 meters per second. We have to calculate the change in the kinetic energy of the ball. So, we have a ball, it's going from one point to another point and from point A to point B, and its velocity is decreasing. We have to find the change in the kinetic energy. So what is the initial kinetic energy? The initial kinetic energy would be half into mass into velocity square. So it would be half into 0.5 into 25, which would be 6.25 joules. Now, for the mass, when the mass is when the velocity is 3 meters per second, then the kinetic energy would be half into mass into velocity. So that is going to be equal to half times 0.5 times 3 square. So that would be half times 0.5 times 9. So that would be 2.25 joules. So this is the final kinetic energy. So the difference in the kinetic energy would be final kinetic energy minus initial kinetic energy, that comes to be minus 4 joules. So there is a decrease in energy, that's why we have this minus sign here. So the kinetic energy has decreased by 4 joules. You can quickly make a note of this. Now we have a body of mass 10 kilograms is moving with a velocity 20 meters per second. If the mass of the body is doubled and its velocity is halved, then we have to find the initial kinetic energy and the final kinetic energy. So यहाँ पर भी क्या दिया है, तो मास दिया है, वेलोसिटी दिया है. सेकेंड केस में क्या हो गया, उसका मास डबल हो गया एंड वेलोसिटी हैज हाफ्ड. So let's see what we get. In the first case, the mass was m1 was 10 kilograms and the velocity v1 was 20 meters per second. Now m2 mass is doubled, so it would become 20 kilograms and velocity is halved, so it would be 10 meters per second. First case, kinetic energy would be half into mass into velocity, so we would get it as half into 10 into 20 square, so it would be 2000 joules. In the second case, the final kinetic energy would be half into mass into velocity square again, so we'd get it as half into 20 into 10 square, so it would be 1000 joules. So that is about this particular sum. So you see, it is pretty simple to solve these kind of sums because we are dealing with only one formula. Either it is mgh or half into mass into velocity square. Let's quickly go ahead with the next example that is there. This is example number 8. We have a truck weighing 1000 kilogram force. Again, they've juggled the units and it is in kilogram force now. Keep it in mind. Apart from that, they have also given the speed. It is changed from 36 kilometers per hour to 72 kilometers per hour in 2 minutes. That's pretty fast. Then we have to find the work done by the engine, and second, its power. Now, it's crucial that everything needs to be in the same unit. So यहाँ पर ये kilometers per hour है, तो that is slightly dicey, उसको change करना पड़ेगा. So first thing first, we are going to change the velocities from kilometers per hour to meters per second. So 36 kilometers per hour becomes 100 meters per second and 72 kilometers per hour becomes 20 meters per second. Mass of the truck is 1000 kilogram force. So we can say that it is 1000 kilograms. And so the work done would be half. So what is the work done? We'd use the work energy theorem here. हमने वो क्या find करना था? Work done. Work done is what? तो work done is equal to final kinetic energy minus initial kinetic energy. Okay. So यहाँ पर क्या होगा वो? So it would be half mvf square minus half mvi square. हाफ m कॉमन है दोनों में, मास चेंज नहीं हो रहा, वी गेट इट एज vf square minus vi square. So that's what we've done here. We have half multiplied by its mass multiplied by final velocity square minus initial velocity square. We put in the values and we end up with the final answer as 1.5 times 10 to the power of 5 joules. This is the work done. Now what is the time taken? Time taken is 2 minutes. So that is 120 seconds. So we can put in that value here and we get the power as work done upon time taken. So it would be 1.5 times 10 to the power of 5 divided by 120 seconds, giving us the final answer as 1.25 times 10 to the power of 3 watts. यहाँ पर ध्यान देना, ये work done है और ये watts है. So we can also write it as 1.25 kilowatts. I hope you've understood this example. Quickly make a note of this, then we can go ahead. Now, this is a pretty interesting example. We have a trolley here and we have a spring. The mass of the trolley is 0.5 kilograms and it's connected to a spring. We have compressed the spring. इसको ऐसे मस्त दबा के रखा है ये साइड में पुश करके और then the trolley is released. जैसे मैं फोर्स छोड़ दूंगा, what is going to happen? The spring is going to come to its normal position. तो ट्रॉली पीछे ढकेली जाएगी. It is important to understand that the horizontal surface is smooth, मतलब friction is negligible. Now what is the potential energy did the spring possess? अब तक अपन ने potential energy देखा था gravity का, अभी potential energy देख रहे spring का. So here mass of the trolley is 0.5 kilograms, velocity is 2 meters per second. Now when we use the force to compress, the spring is having potential energy. जैसे छोड़ देंगे तो that potential energy is going to get converted into the kinetic energy. So potential energy of the compressed spring would be equal to the kinetic energy of the moving trolley. तो मेरा kinetic energy find करना पड़ेगा मेरे को. That would be half into mass into velocity square. I put in the values. मेरा mass 0.5 kilogram है, मेरा velocity 2 meters per second है. It comes to be 1 joule. So this is the potential energy that is going to be stored in the trolley. So I have tried my best to select questions that were different so that we can cover different forms of answering. So learners, these were the numerical examples that have been given in Concise Selina textbook for 10th ICSE. I have tried to solve majority of these sums which I found were important according to your exam perspective. Apart from these, if you have any other queries, please feel free to comment them in the comment section. I would be glad to help you out. If you found this video interesting, please give us a thumbs up, share it with your friends and subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.